So this question here focuses on the skills involved with exponential growth and decay. Now in this one we know it's going to be exponential decay due to the negative power. If that power is positive, it would be exponential growth and head off to infinity. Now in this scenario here, we're talking about a patient being given medicine, and the concentration of the medicine in their blood is modelled by that equation there. Ct equals 11 e to the power of negative 0.0053 t. In this equation, t is the time in minutes since the dose of medicine was given. Ct is the concentration in milligrams per litre at a set time t. Now the first part is it wants us to calculate the concentration of the medicine 30 minutes after it was given, and then in the second part it's talking about when it becomes ineffective and how we can calculate the time for that. So we'll start with part A. Now part A wants to know what the concentration of medicine 30 minutes after the dose was. Now we know that t is how many minutes since the dose of medicine was given. So in this case we know that t is going to equal 30. So what that means is that Ct is going to be given by 11 e to the power of negative 0.0053 times the t, which in this case is 30. Now a question like this appears in paper 2, so it's going to be a calculator 1. So it's now just putting that in your calculator. We just need to make sure we enter the numbers right and we do the right order of calculations there. What we'll end up getting is 9.38 milligrams per litre. That ends up being the concentration after 30 minutes. Now part B is telling us that it becomes ineffective when its concentration falls to 0.66 milligrams per litre. It wants the time taken for the dose of medicine to become ineffective. So what this basically means is it's telling me it wants to know when 11e to the negative 0.0053 t equals 0.66. So what I have to do is start to solve this equation here. So firstly, in order to be able to do it, we want to apply rules of logarithms. Now, to be able to do that, we don't want any coefficients of our exponential there on the left-hand side. So the first thing we always do is get rid of the coefficients. So if I divide both sides by 11, I get e is equal to negative 0.0053 t equals 0.66 divided by 11. Now if I do that and I am just left with a base to a power, at that point I can start to bring in some laws of logarithms. Because if I take the logarithm of both sides with respect to the base, what that means is the base will disappear, the power will just be left on that side as a term on its own, and then it will just be the log on the other side. So for example, what I mean is if I take the natural logarithm ln of e to the negative 0.0053 t, and I take the same on the other side, ln is 0.66 over 11. If I bring the power down, I use my rules of logarithms to do that, 0.0053 t. Now remember, ln is the natural logarithm, so that's log to the base e. So I've got log to the base e of e. Remember, log to the base a of a is just equal to 1. So log to the base e of e is just 1. So all I'm left with on that side is negative 0.0053 t. And that's going to equal ln of 0.66 divided by 11. What I then want to do is I want to find t equals, and in order to do that, I get rid of the coefficient by dividing both sides by the negative 0.0053. So I can then say that t is equal to ln of 0.66 divided by 11, all divided by negative 0.0053. I'd love to see you try and do that in your head. Like I say, luckily this is calculator-based questions, so we can just fire that in a calculator. Now, please enter it in the calculator very, very carefully, ensuring that all the brackets are where they need to be, all the fractions and all the signs are where they need to be as well. And when you do that, we get that the time t is equal to 530.83 minutes. So after 530.83 minutes, the concentration falls below 0.66, so it hits that target and it becomes ineffective at that point. So there we go, we've solved it using the laws of logarithms. Now a point to note, I have taken, at this step here, indicated by the dot, the natural logarithm, ln of e, and ln of the other side as well. Now the reason I have done that is that it eliminates the e, and it actually makes the maths a little bit easier working forward. However, you can take the log of any base number you want, and the laws of logarithms will still apply, so I can still bring my negative 0.0053t down as a coefficient, a constant in the front of the term, but it'll still have the log of e in it. So it could, let's say I took log to the base 12 of both sides. So if I do a star here like this, and I'll put that across here as a bit extra, let's say I did log to the base 12 of e to the negative 0.0053t equals log to the base 12 of the 0.66 over 11. I would still have the e term in there. So I'd have negative 0.0053t times log to the base 12 of e equals the log to the base 12 of 0.66 over 11. I would then still divide by log to the base 12 of e on both sides and get negative 0.0053t equals log to the base 12 of the 0.66 over 11 divided by log to the base 12 of e. I would then have to take that and divide it by the negative 0.0053 and then plug it all in a calculator. I would still get the same answer ultimately at the end of the question. I would still get 530.83. But looking at the maths that's there, that is so much more complex and dragged out than it needs to be. Eliminate the base as early as you can by taking the natural logarithms of both sides. Doing that will just make your life a lot easier. This question here does follow the same format when it's given, but we have to be careful of our maths involved in this one. It can trip us up by moving things around the wrong way or messing up our logs in certain cases. So be very, very careful working with this one. Any log's acceptable, you just up the ante in terms of the possibility of errors and the difficulty of the question if you take a log that doesn't get rid of the base. So bear that in mind when you're doing a question of this style. Now, part A is worth a single mark just for getting to that, the 9.38. Part B is worth 3 marks. First one for dividing by the 11. Second one for then taking the logs and using the rules of logarithms to get to there. And then the third one for getting your t at the end there like that. So that kind of question there, like I say, is a very standard question that comes up in a paper 2 when you're working on a higher exam. It is very common. A lot of times it'll look at exponential growth, sometimes it'll look, at exponential decay, sometimes it'll look at exponential growth. It all depends on what scenario they decide to pitch it at and the difficulty they decide to pitch the question at. Just be aware of your laws of logarithms, how you're working with them, the rules that apply them, and then how we work the maths through. All right? Please bear all that in mind. Remember, we want to make these things as easy as possible. We want it to be as simple as we can. We want it to be easy peasy, lemon squeezy.